All right, so the first question here, the rate. All right, so they're telling us it's a rate. It's already a derivative at which rain flows into a drain pipe. So this is flowing into the drain pipe. Is modeled by the function r, where r equals that. And it's in cubic feet per hour. T is measured in hours. We're going from 0 to 8. The pipe is partially blocked, allowing water to drain. All right, so it's draining out the other end of the pipe at a rate D equals that. Again, cubic feet per hour are our units of the water. There are 30 cubic feet of water in the drain pipe at T equals 0. So we have some water in the pipe already. Part A, how many cubic feet of rainwater flow into the pipe during the 8 hours? Well, flowing in is modeled by R. So if we want to know how many cubic feet actually flow in, we would just integrate the R of T with respect to T from 0 to 8. All right, now this is a calculator active question because they're not expecting you to know how to take the integral of sine of T squared. Right, so we would just go right over to our calculator where I've already got these typed in. If the calculator was on. So if we look, I typed them in ahead of time. There it is. Y equals 20 sine of the variable squared over 35. So it's in Y1. So if I want to do that integral on my calculator, I would go, I don't need to do second. I always do second first. Math, then number 9 for function integrate. We're going from 0 to 8 and it's in Y1. So what was that? Alpha trace, is that it? There we go. Alpha trace is the shortcut to the Y's. And then it's in terms of X. And that looks like a reasonable answer. So 76.570. And it is in, let's see, how many cubic feet? All right, so this was cubic feet per hour. And the dt here would be hours. So the hours are going to cancel out and we will get cubic feet. Yep, so that does check out. All right, so that's A. Not a lot of work there. Just asking you, do you understand the concept? Part B, is the amount of water in the pipe increasing or decreasing at time t equals 3 hours? Give a reason for your answer. All right, so increasing or decreasing has to do with looking at the rates. All right, well, we have this rate in and we also have this rate out. So the derivative for the amount of water in the pipe, I don't know what function we want to call that, but we would look at R of t minus d of t. Is it plus or minus? I'm not sure if it's already negative. No, it is minus. Okay, I was right. All right, that would be the total rate of change of the water in the pipe. And we just want to know what's happening when t equals 3. So we're just going to plug in 3. So it'd be R of 3 minus D of 3. And we want to see what's the sign of that. We don't even care what the actual value is. We just want the sign, but we can find the actual value. So let's see, alpha 4 y1 at the value 3 minus alpha 4, so the other one was in y2 at the value 3. Or you can just type it in with 3 plugged in. And we've got negative 0.313. There was a 6 after it, but if you want. So 3.3 or 314 will work. Either way, it's less than 0. So since that's less than 0, therefore it is decreasing. All right, since the rate is negative. All right, and if they want anything else, is the amount of water in the pipe increasing or decreasing? Decreasing, give a reason for your answer. The rate is negative. All right, cool. So there's C, there's B. All right, we'll take a look at C. At what time between 0 and 8 is the amount of water in the pipe at a minimum? All right, so that's C is now looking for the absolute minimum. And it wants the absolute minimum of the function. Well, we start off with 30. We add, let's see, we're going from 0 to sometime t of r of, I would say t, but I got to use a different variable, r of x minus the water that's draining out, d of x dx. All right, you could use t's here and put x up here. That's fine. You can do it either way. Doesn't really matter, but you do need different variables between the outsides and the inside here. All right, so there's our dummy variable, I guess, x. All right, so that's what we want the minimum for. So if we want to minimize that, we need to take its derivative and set it equal to 0. So the derivative of this would be r of t minus d of t. So we set that equal to 0. So now we go back to our calculator and we say, okay, well, I could just, let's see, I've typed them both into y equals. If I look at the graph, I can just see where they cross. I don't know if I'm going to see it on this graph. Well, it's pretty low there. So I might be able to get out to 8 there. All right, so that's definitely the sine curve, right? Going up and down like that. And here's our drainage. And let's see, they cross both at 0, but oh, there's definitely another point where they cross right over there. So let's do that second trace 5 for intersect. And let's scoot over near that point. And we calculator disappeared on us. We're going to scoot over near that point because I don't want it to give me this 0 point over here. So enter, enter, enter. X is 3.2716. All right, so that's when we hit 0. So now that's the only time in that interval. How do we solve for zeros without graphing on the calculator? This is a calculator active question. As far as solving for when that equals that without a calculator, you're kind of out of luck. You not have a calculator? Because you can use the app without graphing. Is there a solver on here somewhere? I haven't played with it in a long time, so I don't remember if there is a solver on here. Some of them do have a solver where you can just type in the equation and press enter, and it'll tell you when it's like equal to 0 type thing. But I don't see that anywhere on here. No. Yeah, I didn't see it in math. I just looked. Solver? I don't know. Yeah, well, let's try alpha y1. I don't know if this will work or we have to type them over again. Alpha trace y2. And I don't know, that worked. All right, so that works just as well if you want. So it is in math all the way down at the bottom, and then you type in your 2 equations. But I mean, it's interesting to me that it only gave us this answer and not like the other 0 where they cross or any of the other answers. So you might be better off using the graph still either way. So now when we're doing our candidate test, our candidates are, well, we're doing it over the interval from 0 to 8. So our candidates are 0, then this point, 3.2716, and then 8. And then our function is the 30 plus the integral from 0 to t of r of x minus d of x dx. All right, now I'm not going to try and work these out by hand, but the first one's not so bad. If I plug in 0 here, the integral's from 0 to 0. I'm just getting the 30 to start, and that's what they said it was to start, was 30 cubic feet. All right, for the second one, yeah, I'm definitely going to have to use the calculator to integrate that. All right, so out of that, math 9, we're going from 0 to 3.2716 of y1. So alpha trace, there it is, y1 minus y2. So alpha trace, I could just press the number 2, I guess. And let's see, our variable was x. And we also have to have that plus 30, which I left out. So I'm just going to type it here at the end, plus the 30. And I get 27.96 and so on. Wait, I need 3 decimal places. This is AP Calc 964. 27.964. Well, that's definitely less than 30. Now let's try it with 8. So we'd plug in 8 there, and I think we're going to get a bigger number. But I'll remember to do the 30 first this time. So 30 plus math 9. We're going from 0 all the way to 8. Probably should have just rewritten this and just changed that boundary, but oh well, too late now. Alpha trace 1 minus alpha trace 2 with x as our variable, and 48.53 or 543. All right, so the minimum, so at what time is the water an absolute min? Justify your answer. So at time 3.2716 hours, the water is at a minimum. There we go. D, the pipe can hold 50 cubic feet of water before overflowing. For T greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write, but do not solve an equation involving one or more integrals that gives the time W when the pipe will begin to overflow. All right, well, that's really not so hard. It's just, so this is the amount of water in the pipe, and we're saying it will overflow when it hits 50. There's D. All right, there you go. All right, so let's look at the grading on this. Change T to W. Oh, they did want W. I don't know if it makes a difference, but yeah, that would be W. There. Feel better now? I don't think it would make a difference in the score, but there you go. All right, so the first one, then we got the 76.57. Yep, there we go, 57. 76.570, we got that. And we had the right integral set up. Cool. Let's see, considers R of 3 and D of 3. Yeah, we did R of 3 and D of 3. We subtracted them. If it just says considered, I mean, even if we added them, we'd still get the point there. So we got that. And then we have our answer, which is this, and a reason. So that it's decreasing since it's negative. All right. And they said because the rate in was less than the rate out, that's fine too. That would work too. It's for T greater than 8. Yeah, it is for T greater than 8. The next one considers when they're equal to 0. We did that. We didn't write the 0, but we wrote the other one. We had the 0 already because it was an endpoint. Then we had the 8, and we had that. We did our chart, and then we said it was at a minimum at the time, the 3.27, and so on. All right, and the justification is the chart. And then finally, the last one, we want the integral and the equation. So the integral here, basically, if you had this for one part, that's 1 point, and then making it equal to 50 is the other point. And yes, it would be for T greater than 8, but this is never equal to 0 before that because we already found that the minimum it was before that was 27. So we know it's not going to be, and the highest it was after that was 48. So we know it hasn't equaled 50 between 0 and 8 already. It's going to be sometime after 8. Looks like it's going to be pretty soon after 8. Like 8 hours and 10 minutes or something like that. All right, the next one. And again, this is a very straightforward chart problem. They do like these problems. We have some sort of rate here. This is meters per minute, and this is time, minutes. So Joanna jogs. We got a kick out of this last year when Joanna was in class, and she was also on the cross-country team. So Joanna jogs along a straight path from 0 to 40 time. Joanna's velocity is given by the differential function v. Selected values of v of t, where t is measured in minutes and v of t is measured in meters per minute, are given in the table above. Part A, use the table to estimate the value v prime of 16. Well, they love to ask these questions, and really we just look, say, where's 16? Well, 16 was going to be between these two. So we just want the slope then between those 2 points. So we'd say v prime of 16 is roughly equal to, or approximate to, let's see, negative 220 minus 240 over 24 minus 20. No, I picked the wrong interval. Sorry, those two. I was like, I don't remember having the negative in here. There we go. Realized it before. You guys said it. I get the point there. All right, so these 2 points is where 16 is between. I can count. It's questionable sometimes, but yeah, I can count. So we get 240 minus 200 over 20 minus 12. So that's 40 over 8. That looks like 5. It's the rate of change in the meters per minute. So this would be meters per minute or per minute squared. If you want, this was meters per minute on top. and this is minutes on the bottom. So it'd be meters per minute squared. All right. So we just had to estimate. It didn't even ask for us to like explain what it was or anything like that, interpret, which is like what they usually do. And we'd say at time t equals 16 minutes, her acceleration is approximately equal to 5 meters per minute squared. All right, part B. Using correct units, explain the meaning of the definite integral, the integral from 0 to 40 of the absolute value of the velocity dt in the context of this problem. All right. So the integral from 0 to 40 of the absolute value of v of t dt. All right, well, since it's absolute value, it's the total distance traveled. If we didn't have the absolute value, it'd just be the displacement between 0 and 40. So this is the total distance traveled by Joanna from 0 to 40, and then where's in minutes? It's kind of a strange thing just to run straight for 40 minutes. All right. All right, approximate the value using the Wright-Riemann sum and 4 subintervals. Well, it's going to be the 4 subintervals right here. So like we've got 1, 2, 3, 4. Amazing how that works out. So let's go ahead and approximate that value. So the integral from 0 to 40 of the absolute value of v of t dt t is approximately equal to, let's see, so the width of this interval is 12. And the height, let's see, we're going on the right side. So the right side would be that one. And it is technically the absolute value of that because it's absolute value. Plus the width of this one, 12 to 20 is 8. Plus or times the absolute value of the right side, which is 240. Plus the width of this one is 4. Now here's where the absolute value comes in because we have this negative 220 here. Plus, and then we've got the width here is that 16? And then the right side is the 150. All right, so this would be, let's see, 2,400, 8 times 24. I don't know that off the top. 8 times 240 plus, let's see, that's going to cancel out. That's 880. So the negative sign cancels out here. And then we have 16 times 150, 225 plus another 15 is, I don't know, that's too much work. 240? Yeah, oh well. Anyways, we could leave it like that. It's AP exam. We don't have to work that out. We can just leave it like that. We do want to work out the absolute value though. It's like, so if you just said this is 12 times 20 plus 8 times 240 plus 4 times 220 plus 16 times 150, that would be a perfectly acceptable answer. All right. I don't know what that works out to. Probably a big number. Part C. And this was a non-calculator question, if I remember correctly. So part C, Bob is riding his bicycle along the same path. Good for Bob. From 0 to 10. Bob's only going for 10 minutes. Joanna's going for 40 minutes. This just doesn't seem fair. Bob's velocity is modeled by the, well, B of t for Bob, I guess. There we go. Where t is measured in minutes, B of t is measured in meters per minute. Okay, so same sort of units and that sort of stuff. Find Bob's acceleration at time t equals 5. Imagine being Bob. We didn't have any Bobs on the cross-country team. All right, well, if this is velocity and we want acceleration, we take the derivative. So acceleration would be b prime of t. This should be a very easy derivative. So we're just bringing down the 3. So 3t squared minus, bring down the 2. We get 12t to the first. Derivative of 300 is 0. There's our derivative. So that's our acceleration. And then we plug in 5. B prime of 5 equals 3 times 25 minus 12 times 5. So that's 75 minus 60. So that looks like 15. And this is acceleration, so meters per minute squared. And it just said to find it, didn't say to interpret it or anything, so there it is. If we had to interpret it, we'd say at time t equals 5 minutes, Bob's acceleration is 15 meters per minute squared. And finally, parts D, based on the model B from part C, find Bob's average velocity from 0 to 10. All right, well, the average velocity is just a formula. It's 1 over B minus A. So 10 minus 1, 0, sorry, 0. Then the integral from A to B of his velocity function. So I could just write b of t in here, but I guess we're gonna have to actually do it. So t cubed minus 6t squared plus 300 dt. Probably gonna get a point or two just for writing that. Now we actually want to solve this. We want to work it out because it says to find his average velocity. So this is going to be 1/10 the integral. Actually, I'm going to just go ahead and take the integral. So t cubed is, usually we have to do some sort of substitution or something, you know. So this is t to the 4th over 4 minus 6t squared over, or sorry, 6t cubed over 3. So 6 and the 3 will cancel. So we'll have 2t cubed plus 300t. And this is going from 0 to 100. All right, we're going to plug in 100 first. So we get 1,000, no, 10,000 over more than 10,000. Forget that. Lots of zeros. Oh, why do I have 100 here? 10, there we go. So I was like, it should just be 4 zeros. They can't do that, right? 2, 3, 4 zeros over 4 minus 2 times 3 zeros plus 3 times, there we go. And it's all minus 0 because plugging in 0 gets a 0. We could leave it at that if we wanted to. All right, you could just try and keep working this out. We could bring the 1/10 in, actually. That might be the easier thing to do. So it's going to cross out at 0 everywhere. So here we're going to get 1,000 over 4 minus 2 times 100 plus 3. So this is what, 250 minus 200 plus 3. So 50 plus 3 is 53. And let's see, do we have some units there? Average velocity, so this was meters per minute. All right, so hopefully we did the math right there. Let's see how we did. Oh, it's kind of blocked. I can't see that. Oh, well. All right, so we had the 5 meters per minute squared. That was great. And it's, yep, we got the approximation right. So we did use the right sign there. Explanation, it's the total distance she jogs in meters from 0 to 40 minutes. Yep, we had that explanation spot on. We're pretty close enough. Right Riemann sum. So then we did the right Riemann sum. That's this line right there. And then the approximation, basically anywhere from here on down would count for the approximation. So it looks like we had all the right things there. Just I wasn't going to work all those out in my head. His acceleration, we took the derivative. So there was the derivative b prime, and we plugged it in and we got 15 and we had the right units. So that was right. The average velocity, so we'll get 1 point for the integral, 1 point for taking the integral, and then 1 point for getting an answer. Did I lose the 300? Did it change to a 3? It did change to a 3. Fixed it. This was a non-calculator question, yeah, which means you don't have to work out the numbers. Like you could get to right here and stop and just not work it out from there. That's perfectly fine. I can't even see what numbers below there. But I would have lost the point for here because I changed my 300 to a 3 somehow. Oopsies. It happens. But yeah, you guys don't actually, I mean, no one's watching. I'm not going to tell you to use your calculator, but no one's watching. I mean, they might be able to tell if you went from, you know, this to here's an answer, but, you know, no one's keeping an eye on you while you're taking this test. Just FYI. All right, so on to the multiple choice. So there were a few that I wanted to check out, but not too many because really most of you did quite well on this. So 13 was one of them. So this is 13 right here. So refer to the graph and the information below. So here's a graph. This is f prime. I know you can't really see the prime in there, but it is f prime. And it says the function f is defined in a closed interval from 0 to 8. The graph of the derivative f prime is shown above. For what value of x does the absolute minimum occur? All right, well, it's asking you basically to do a candidate test. If it's asking you for the absolute minimum, And the candidates would be 0, and then 4, and then 6, and then 8. All right, but if you want, we can do another test here while we're doing this. So this is f prime. So we can also look at the sign of f prime to see just if is it increasing or is it decreasing before those points. So here's 0, here's 8. So we can actually eliminate some of them. So here's 4, here's 6. So f prime is positive here. It's positive, and I say it's positive just because it's above the x-axis. Same here, above the x-axis, then below the x-axis. So that means f will be increasing, increasing, and then decreasing. So 4 can't be a minimum. 6 also can't be a minimum. Our only option is 8 or 0. So now the question comes in, okay, well, what's the area? How much area are we adding between 0 and 8? So at 0, we've got some value for our function. So it's whatever f of 0 is. At 8, we've got f of 0 plus the integral from 0 to 8. All right, now the question is, do we think the integral from 0 to 8, with all this positive area here and all this positive area here, and then this little bit of negative area down here, is going to end up being a positive answer or a negative answer? Right? That's basically what it's asking. And if I was a betting man and I can just look at this and tell like, hey, with this one and this one, maybe they cancel each other out, but we still have all of this area over here that's much, much bigger and all positive. This has got to be greater than 0. So that means this is going to be greater than f of 0. So that means our minimum value is going to happen at 0. That is our absolute minimum. So both endpoints, not just the 8, guys. Yeah, I think every single one of you just put 8 for this one. This person just left it blank. But every single one of you guys, I think, put 8 that answered. All right, next one we all had an issue with was 20. And maybe not all, but a good number of 4 of you had an issue with it. All right, and the problem here, besides not having fancy math type, is that we want the total area of the region bounded between these two curves. Well, these curves cross each other between 1 and 3. That's the problem. So this is a parabola opening up. This is a line going down. All right, so if, well, I don't have a graph of it down there, but if we want, since everything is technically calculator this year, maybe I shouldn't say that out loud. All right, but if we want, we can go to y equals, let's just clear these out. I'm done with them. So we've got 6x squared. I could probably graph that not too hard without using the calculator, but you know, I'm lazy. And then negative 6x, it's a line going down with a slope of negative 6. We'll just go ahead and look at the graph. We only care about 1 to 3. So there's one of them. The other one's going to go pretty steeply down, I think. There's the other one. All right, well, let's change the window a little bit. So we only need to go from 1 to 3. So let's go just from 0 to 4, a little bit out, a little bit past it on each end. And we definitely need to go down farther, negative 20 maybe. We didn't need to go up any. All right, and now let's check it out. All right, so now if we were going to integrate this, so this area here has the line on top, and this line is the negative 6x. So we would be integrating from, actually, we're starting at 1. So it's not even this whole area. We're starting here at 1. And then we're going to 2, 3. It's not my best drawing. But we're going to go from 1 to, I'm just going to assume they cross here at 2. That looks pretty good, like 2. 1 to 2 of the line on top. So negative 6x minus 6x squared minus 18x dx. And then we're going to add to it the integral from 2 to 3 of this section over here. And this one's got the parabola on top, the blue one's on top. So I'm going to have 6x squared minus 18x minus negative 6x dx. So the top one minus the bottom one. And then we got to work out both of those integrals and then add them together. Those shouldn't be very difficult integrals to work out, especially with some terms combining. And it looks like we get 12 from that. Or you can type it into your calculator. All right, but that is how we would do that one. So yeah, you have to split it. I think if you don't split it, I think that's, I'm trying to think, most of you, I think, put 4, and that's what you get if you don't split it and just assume one of them's on top. One time I didn't graph it. Yeah, well, so that was 20. And then the last 4 here, which I believe are all sequence and series stuff. I don't even think I looked at this one. I looked at 25 and 26, but yeah, 4 of you missed 24 here. So a Taylor series for ln of x centered at 1 is that, okay? Let f be the function given by the sum of the first 3 non-zero terms in the series. The maximum value of the difference for x between 0.3 and 1.7 is what? All right, so this is an alternating series. All right, so that's one thing to notice. So it's an alternating series. So that means the maximum value of the difference, the error, in other words, is just the next term. So it says the first 3 non-zero terms. So that'd be 1, 2, and 3. So that means the next term would be n equals 4. So if we plug in n equals 4 and we look at the absolute value of that, we're going to have negative 1 to the 5th. That's going to go away. We've got x minus 1 to the 4th over 4. And now we've got the 2 different endpoints we can try. We can try 1.7 or 0.3. Either one we plug in gives us, well, 0.7. Like one of them's positive 0.7, the other one's negative 0.7. We're going to take absolute value anyway. So what we get is 0.7 to the 4th over 4. All right. And now we just got to work that out. That seems like that won't be this answer. But I don't know. Maybe check. Oops. Calculator, you're never in the right spot, buddy. Let's get out of that. 0.7 raised to the 4th divided by 4. Yeah, that's not it. What am I missing? I don't know what I'm missing. It doesn't show me anything down here either. It doesn't give me answers, which is kind of annoying. Yeah, alternating series error bound should just be the next term. The first 3 non-zero, so it'd be 0, 1, and 2. Oh no, it's just starting at 1. I don't think it has anything to do with that. Thank you. 1 minus 1 does equal 0. Who got this one correct? I don't remember who got this one correct. Let's see, this was number 24. Anthony got this one correct. I don't know if he guessed or what, but yeah, you got it correct. No, never mind. Sorry. Octavio, you got this one correct. You're the one who suggested asking. Sorry, I was off by one person here on my chart down at the bottom of the page. Yeah, I thought there was, but it's not showing up here. Let me see if I can get to it. Let me see if I can do that. And that was 20, whatever. 24. Let's see if I can get answers here. Oh, please let me just skip to 24. Yeah, there we go. Is it not going to show me 24? There you go. There's 24. And does it give me an answer? That's definitely not an answer. That doesn't look like an answer either. I don't see it giving me an answer anywhere. Oh, no. Apparently not. I don't know if it's going to give me all of them or not. It's taking a long time to load. All right, well, that doesn't seem to be working. Let's see, where was I? Oh, well, that did. Wonder if it'll show the multiple choice on here. It just shows answers. Yeah, it doesn't show me the actual. Useless, just useless. All right, well, let's move on. 25, and I totally understand missing this one. This one was kind of a mouthful, and I couldn't even read the notation. I had to look at the other version to figure out what was going on. But what it wants is the 30th derivative at 3 for f, and it's giving you this polynomial. All right, well, the 30th derivative is going to be the coefficient of the x minus 3 to the 30th. So like, remember, it's f 30 of 3 times x minus 3 to the 30th over 30 factorial is the actual term. All right, but in order to get 30 up there, n actually has to be 15. All right, so that's the trick, is we're actually plugging in 15 here for n. So we're getting -1 to the 15 plus 1, so that's 16. We're getting x minus 3 to the 30th, and we're getting just a 15 factorial down there. So -1 to the 16th is just 1. So that we don't even need to include that. So now we need these two things to be equal to each other. So what value here will make that equal to that? Well, we don't need these. Those will cancel right out. So the way we solve this is just multiply up to 30 factorial. So we get 30 factorial over 15 factorial will equal the 30th derivative at 3. All right. I looked, most of you, a lot of you had gone with the negative, and yeah, you're just off by the sign term there. Yeah. All right. Yeah, but that one was definitely a tricky one, especially realizing 30 here, then n had to be 15 because you want 30 as the exponent. That was definitely threw people for a loop, I think. Or you just didn't know what was going on, which is okay too. All right, next one. Which of the following series converges for all real numbers x? All right, so these first three, well, I don't know which way I want to try and explain this, but if x is 1 in this guy, that definitely diverges. It's 1 over n. All right, that'd just be the sum 1 over n. That's the harmonic series that diverges. All right, so clearly not that guy. This one, if x is bigger than 1, we've got an exponential on top that just keeps increasing. Doesn't matter, we have n squared on the bottom, we have an exponential on top. If you want, you could check with, the interval and radius of convergence stuff, but this one is also going to diverge for x greater than 1. All right, just because that's geometric on top, that's definitely going to diverge. Even with that divided by n squared is not going to help. All right, this guy's bigger than either one of these two guys because he has even less on the bottom. So he's also going to diverge. If you want, you can do a comparison test between that one and that one. So, but it will also definitely diverge when x equals 1. All right, if x is less than 1, it will, like I think from -1 to 1, it will converge. And it will converge at -1, but not at 1, but otherwise it won't. These two guys are the ones we really want to check out. All right, so let's try the ratio test on each one of those because they have factorials and exponentials. So we would do the limit as n goes to infinity of e to the n plus 1, x to the n plus 1 over n plus 1 factorial divided by this guy, so times that guy flipped, n factorial over e to the n, x to the n. Gosh, I hope they don't make you try and write this with math type. So the n factorial is going to cancel completely and just leave us with an n plus 1. E to the n is going to cancel completely and just leave us with e to the first. X to the n is going to cancel completely and leave us with just an x to the first. So we're getting e over n plus 1 times the absolute value of x. Needs to be less than 1. All right, well, if we move this over, we get the absolute value of x needs to be less than n plus 1 over e. As n goes to infinity, this goes to infinity. So that means our radius of convergence is infinity. That means it'll converge for all x. So this guy's our winner. If we check this one, it's going to be the exact same thing upside down. Like it will just be, these would switch places. Right, so we'd end up with the absolute value of x is less than e over n plus 1, which goes to 0. Yeah, you don't want to have to type that in. And then show the canceling. You're going to show them crossing out on there too. All right, so I'll mix this better next time, I promise. So let's clear all the drawings here. Let's give me back to my mouse. And let's get this, just stop recording.